This might come off as completely insane, but it actually works. This panel shows us a strange but effective method to approximate the mathematical constant pi. Take a large piece of paper and then draw parallel lines with two toothpicks long distance between each one. Once that's done, take a bunch of toothpicks and then literally throw them on the paper. Now that's done, all is left is to count how many toothpicks touch one of the lines and then divide the total number of toothpicks by that. The more toothpicks you use, the closer you will get to the real value of pi. But why does this work? When dropping the toothpicks, we introduce two variables. 1. The distance from the toothpick center to the nearest line. 2. The angle the toothpicks make, which ranges from 0 to pi in radians because angles beyond that are symmetrical. Thus, the probability of touching the line can be expressed as 2 multiplied by the length of the toothpick divided by pi multiplied by the distance between lines. Since we set the distance to twice the length of the toothpick, we are left with 1 divided by pi. Therefore, pi is equal to 1 divided by that probability, which we can find by dividing the total number of toothpicks by the number of those that touch the line. The idea of dropping toothpicks or needles randomly to estimate a number comes from the Monte Carlo methods. The idea is to use random samples to generalize a result rather than calculate everything. For instance, if you wanted to estimate the average weight of a population, instead of taking all the citizens and weighing them one by one, you can take a random sample group and hope they represent the whole population. The larger the sample, the closer you get to the real value. Fun fact, the same method is used in video games. For example, to calculate the trajectory of light and find out where the shadows fall. Instead of calculating everything and straining the user's hardware, they simulate only some and hope they represent the whole. This method is so powerful that it is used to simulate phenomena in quantum physics, the mother of all randomness.